Hi guys and girls, I'm Obsidian Ant, and today we're going to take a look at how to find terraformable planets within the habitable zone of a star. Now the first thing you want to do is go to the galaxy map and choose the view tab and then go to the map option. There's a drop down there that you just saw me select, and you need to choose star class. This allows you to filter the stars by star type. Now there are many different types of stars out there, but the ones we want for our purposes are F, G, K, M and L. Our own star is a G-type star. It's a main sequence star like all the others we're going to look for here. Now the other thing I do when looking for these types of planets is to put my navigation onto economy routing and then just choose a destination. Economy routing allows me to do the greatest number of jumps within the shortest distance. This means that I can pass through a lot more systems within any given time span. It's basically about me just getting through as many systems as possible without me travelling too far. So all of these stars have different properties. All of these burn in different ways, they're different sizes, they have different masses, and they give off different types of radiation. Only a few of them are actually amenable to life. Now there are many stars out there, and this guide is by no means an exhaustive strategy. It's not the only way to find these sort of stars, but it should increase the chances of you finding the sort of planets you're looking for. And of course this will also include Earth-likes. You'll still probably have to go through a good number of systems before you find what you want. Now this is the first system on the route, and all we've got is gas giants. No metal content planets there, no water worlds, nothing like that. So time to move on to the next system. And essentially this is what you're going to need to do. You're going to need to jump from system to system until you find what you're looking for. But as I said, this does increase the chances of you finding what you want, and hopefully you won't have to jump too many systems to find a habitable world or a world that can be terraformed. Normally I'll find one every 5 to 8 jumps or so. Now there is some science behind how and where the habitable worlds can be found, which holds true to the real world galaxy. And of course, as Elite is based on the real-world galaxy, Stellar Forge, the system that generates all the star systems, actually follows the rules of that science pretty accurately, and we'll get to that in a little while. I'll show you a little bit more about that. Okay, so this is a second jump, and we've done very well already. It looks like that might be a water world, possibly an Earth-like, but looks very much like a water world, and a bunch of high metal content planets there as well. Now it's likely that these will be habitable in the sense that they could be candidates for terraforming. We'll need to get a bit closer to have a look at that. Now I find the whole concept of a habitable zone within a star system quite an interesting subject, and there is a website out there that simulates habitable zone calculations and allows us to mess around with the formation of a star system a little bit. So whilst we're en route to this planet here, let's go and take a little bit of a look at that and see what it's all about. And this is on the website for the University of Nebraska, Lincoln, and what it does is calculate where the habitable zone is within any star system, and by default it's showing our own star system here. We've got Earth right there and the habitable zone that it's existing within. Now you can change the parameters of the star system to make it match up with star systems of different type, but we're going to leave this one as our own solar system at the moment. But one parameter we can change is the age. It's currently set to 0 years, which is essentially when the system was formed, and we can move that forward to the current timeline, which is between 4 and 4.5 billion years. And as we move forward, you can see that the habitable zone moves outwards, and this is due to the changes within our star as it ages. So the habitable zone being the large band that it actually is, and the fact that it moves out relatively slowly, has given life on Earth the time it needed to form. In our case, quite a few billion years. And now we're closing in on our current timeline. You can see we're right at the very edge of the habitable zone. So that would imply that life on Earth has already used up the bulk of its time. As our star continues to change, the habitable zone gets pushed out further and further until at around 5.5 billion years, so 1 billion years from now, only a quarter of the time that we've actually used, Earth becomes uninhabitable. And of course the habitable zone continues to move outward until it covers the orbital ring for Mars. Just look at that. And Mars would now be in the habitable zone. And as the habitable zone goes out so slowly, it gives Mars quite a lot of time there. If there is any building blocks there for life, we could well see life forming on Mars, at least in some form. 4 billion years is a lot of time. You can see Mars has almost the same amount of time within the habitable zone as Earth has had. So I guess anything is possible. And as we continue to move forward, the habitable zone moves out towards the outer edges of our solar system. Now something remarkable happens at 12 billion years. See Earth getting pushed out as our sun goes supernova and turns into a white dwarf. You can see it swells right up and pushes Earth away, and as it explodes, it renders Earth a complete husk, and the habitable zone then makes a return toward the inner edges of the solar system. The habitable zone keeps shrinking down as the sun gets smaller and smaller, until the point where life within our star system is impossible. For the star system generation, Elite uses a system called Stellar Forge, and this controls all the parameters of a system. It controls the type of star we have, and it determines all the geology and the history of every planet type, and it also of course controls where the habitable zone is within a star system. Now Elite and the habitable zone calculator don't 100% correlate with each other, but the calculator can give you a little bit of an indication of where to look and what to look for when looking for valuable planets. So whilst I've been talking, we've arrived at the planet here, and it turns out it is indeed a water world. Jumping to the system map, we can see whether or not it is terraformable. Let's have a look. And yes, this planet is a candidate for terraforming, and that means that the planet must be within the habitable zone of this system or thereabouts. Sometimes they can be just inside the habitable zone, sometimes just on the outer edges of the habitable zone, but it's usually pretty close. There's a couple of other planets here as well that look like they've got atmospheres of some type, and the question is, are these also candidates for terraforming? My suspicions are the ones that are further out probably aren't, and the ones nearer the star probably are. And that suspicion is based on the experience of exploring literally thousands of different star systems. Now, whilst you can't use the habitable zone calculator I showed you to actually work out where habitable planets are within Elite, what it does teach you is the signs to look for of where you're likely to find the terraformable planets. So we're now heading towards the third planet from the star. The one we just looked at was the fourth planet, and we're going to check this one out as well. So we've got a high metal content planet here, and we know it's definitely got an atmosphere, but the question is whether it's terraformable or not. And yep, as I suspected, it is indeed terraformable. I'm now going to go look at the second planet from the star. This one I'm a little less sure of where it could be, because obviously the habitable zone is only a certain width across, and if you go in too close or out too far, you're not going to be within that, and you're not going to find terraformable planets. But the chances are that this one still could be. Another scan underway. Now, for those that you're a bit unsure, the reason we're looking for terraformable planets is because they're a lot more valuable than just regular planets. The ones that are candidates for terraforming will give you a lot more credits when you come to sell the data. And yet again, this one is a candidate for terraforming. So we've got 3 in a row there, including one water world. Now that's quite a bit of money when you actually come to selling this data, and they're quite some good discoveries to have your name attached to them as well. It's always nice to get your discovered by tag for water worlds, and especially Earth-likes if you can find them. Continuing on with the method of only jumping to systems with stars that match the F, G, K, M and L type, I did another 5 jumps and got into this system, did a quick blast of the discovery scanner and found 46 objects. And what did we have? Well, we got a few metal content planets here, a number of them with atmospheres as you can see, and it looked like we also have a water world there as well. So as I said, whilst this method of finding valuable planets doesn't guarantee you success, what it does do is, at least in my experience, increase your chances of finding the things you're looking for. And indeed, here we had another water world that was also a candidate for terraforming. So I hope that helps a little bit. As always, thanks for watching, and I'll catch you guys and girls next time.